everyone, welcome to the episode 105 of SoLeadSaturday. Our today's guest, Dennis, is recognized as a world leader in robotics and computer science education. He has helped more than 20,000 educators understand how robotics and AI will transform the workplace and has trained hundreds of educators on best practices for teaching robotics. His strategies for increasing engagement in robotics and programming courses have been developed through direct interaction with more than 18,000 students and have proven successful across all grades and levels of academic ability. Schools that follow Dennis' recommendations have seen enrollment in robotics and computer science programs increase by more than 1,000%. His presentations have been described as paradigm changing and something all educators needs to see. One more item that is interesting but not in his bio is that he recently did a day of robotics inspiration where he did free webinars for students from around the world. He started in New Zealand and worked their way around the world over a 24-hour period. He was extremely tired at the end, but it was worth it. They had 350 schools sign up and they projected more than 24,000 students in the attendance. That's a lot of people inspired within a single day. He will do another one sometime in the spring and see if he can get that number up to 100K on the second round. So if you would like to actually just check out their website for more details, robotics.education, and you can get to know more about it. So right now, let's just welcome him and hear more about his career journey. How did he find his area of interest and managing to lead that? Hey, hi Dennis. Very happy to have you on the show and really appreciate all your time and consideration being on the show.
Thank you so much. I'm excited to be here today.
I'm very excited because I can't wait to see your demo as well on the robotics, and I'm sure that audience out there will enjoy that demonstration as well. So to begin with, we have our very generic segment, which is passion or the interest. So how did you find your interest in robotics engineering and what motivates you to be where you are today?
My interest in robotics came about very organically. I've been teaching robotics for about 8 years. And if we had met 9 years ago and you said I would be involved with robotics, I would have told you that you were crazy. And so my background is not robotics or programming. I didn't learn this, professionally in school or in university. I had somebody that I was employing that was building robotics in their spare time. And so he was working for a company that I had back then. And every couple of days, he'd come into the office and he'd say, look, my robot can drive around the room without crashing into things. Look, I can have a conversation with my robot. And it was all pretty interesting stuff. And, the curious thing to me was this goes back, 8 years ago, maybe 9 years ago now. And I didn't realize that I was looking at world-class robotics because he had hacked a Wall-E toy and turned it into a robot. So I'm like, oh, that's cute. Wall-E's driving around the office. But he was using self-navigation, and then it's like, he was having a conversation with the robot. And I thought, oh, that's interesting. He's talking to Wall-E. And what ended up happening was I started to understand that what he was producing was a really incredible robotics platform. And he would put a video out on YouTube, and people would say, hey, this is incredible. How can I, or can I get the software? Can I get the hardware? So he'd solder it up and send out a couple of boards. Now, at that time, it was interesting because he's a top-notch programmer. And so what I started to recognize is he's getting more and more requests for his boards and his software. I'm like, oh, this is bad. I'm going to lose my programmer. but we had become good friends through the process of working together. And so I tried to start to help him pursue his passion. And so I started to understand the impact that robotics and artificial intelligence was going to have on the entire workforce. And I started to go talk to educators and demonstrate the product that he had created. The educators told me they felt that it was incredible. So I went back and I said, hey, you're sitting on a really great product here. But one of the interesting things that I also ran into was that as I was doing more research, I started to understand that robotics and AI is much larger than just individual industries, and it will completely transform the workplace. But when I was talking to educators, educational leaders, ministries of education, just really helping my friend out, I started to understand that this was terribly misunderstood. So at that time, I put my company aside and started getting into robotics. And so the whole thing happened very organically for me. And now 8 years later, I've demonstrated robotics to more than 18,000 students.
Wow.
I've helped more than 20,000 educators understand how robotics and AI will impact the workforce. And we just did an event a couple of weeks ago called the Day of Robotics Inspiration, where over the span of 24 hours, I did a whole bunch of free webinars for students from around the world. So we started in New Zealand and worked our way around the world. And we had 350 schools sign up with a projection of 24,000 plus students that we were able to reach and inspire to learn robotics in a single day. So that was just fantastic. I was exhausted at the end of it, but incredible to be able to make that level of difference in just one day.
Wow, this is amazing actually. I'm already thinking that this episode is going to be a lot of fun as well as a lot of educational episode for the audience. And I can't wait to see your demonstration that we are talking about. So would you like to give us a quick demo of how robotics work?
Yeah, sure, I can. I'm happy to do that. So one of the interesting things that I discovered when I was doing, all of my presentations for students was that, knowing that all of our kids need this education, and then seeing how the level of engagement that schools typically get. And within North America, the average level of engagement was at the high school level for schools that were offering robotics clubs or programs, usually about 3% of boys, 0.3% of girls. So, from my perspective, imagine this, we're talking about a situation where, I believe all the kids will need this education because it's going to change every single industry out there. But 3 girls out of 1,000 are getting this education today in schools that are offering it. And only 30 boys, right? And so there's 1,967 students not getting this education. So when we started teaching robotics, we tried to focus on how do we get the maximum level of engagement. And really, there's 3 things we've determined that everybody needs before they're interested in learning this. Because the truth is, you can imagine if we're only getting 3 girls, or if everybody else is getting 3 girls out of 1,000, the majority of girls and boys think that robotics is not for them. It's gross, it's intimidating, lots of different reasons. But what we wanted to focus on was how do we get the engagement up? So the 3 things they need are relevance. Why should I care about robotics? Inspiration, it has to look fun. And the third thing is confidence. So I'll just quickly show you how we get such high levels. And when we talk about what the high schools typically achieve, when we do our presentations at the high school level, we get 25 to 45% of boys and girls wanting to learn robotics. So for a school with 1,000 girls that has 3 girls learning it, we can take that school up to 250 to 450 girls almost overnight. And at the middle school level, we get 95%. That's a lot of stats. But the big way that we do that is we can communicate with this robot with computer, Android phone, iPhone, tablet, Xbox 360 controller, virtual reality glasses, so you see what the robot sees. You move your head, the robot will move its head. A Wii remote, you lift your arm up, the robot will lift its arm up. But my favorite way to communicate with this robot is like this. JD, show me how strong you are. JD, show me how strong you are.
Wow.
And you can imagine when I go into these presentations, I talk for 5 minutes about the future and how robotics and AI will be involved in all these careers. But I know that the kids, are only semi-engaged. And I'm like, I can keep talking for the next 55 minutes if you want, or I can show you what this robot can do. And I know everybody wants to see the robot, right? So we get to do the push-ups. And once the robot responds to my voice, now I've got everybody's attention. JD, what else can you do?
Wow.
And now I programmed those in about 20 minutes. Very early on in my robotics, education or growth. And what I can tell you is any 4th or 5th grader could program those in about the same period of time. This next one was programmed by an 8-year-old girl. JD, can you sing Happy Birthday?
Happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to you. And many more.
And then you can upload your favorite songs and stuff. So if I'm talking to young children, I'll say, you know, JD is a bit of a young robot, not really sure what it is yet. Let's ask a question and find out if he knows. JD, are you a bird? So one of the things we're doing when we do this demonstration is I keep talking to the robot. I'm making it out like it's a personality. And I'm not giving it instructions where, you know, I might say, JD, do push-ups. I'm saying, show me how strong you are. And he's kind of reacting with some attitude, you know, it does the push-ups and stuff. It was interesting. The first time my daughter saw the robot do a headstand, she picked it up and gave it a hug and said, good job, JD, good job, girl. And I was totally freaked out. Like, this is really bad. My daughter has hugged a robot. And I just watched some sci-fi movie about somebody who was in love with a robot, and it didn't end at all well. And so I was like, oh no, this is really bad. And my boy, you know, so she said, good job, JD, good job, girl. My boys were like, that's not a boy or a girl robot, it's a boy robot. And I thought that was interesting because they both identified the humanoid robot as being of their own gender. But beyond that, you know, the big thing for me was that I was freaking out because my daughter hugged a robot. But then I started to, you know, to think after a couple hours, I was like, wait a second, your daughter hugs teddy bears. She plays with Barbie. She's not going to marry a teddy bear or a Barbie, right? You know, it's a scenario where she's got an emotional connection with that robot. And if I work with that emotional connection, I can use that to bring all kinds of STEM education to her. And so that's really what we focus on, is we have a whole lot of different ways that people can build an emotional relationship with the robot. They've all got built-in cameras, so they can be programmed to recognize colors, glyphs, QR codes, objects. Everybody's favorite object is their own face, so the robot can recognize them, greet them by name, right? So we've got lots of ways to get kids that are not necessarily as interested in engineering. They're more interested in the robot interactions, but to make the robot do increasingly cool and awesome interactions, we teach them engineering and we teach them coding. And they're excited to learn it because the output of the robot is so cool. And if I can just share my screen for a second, I'd love to show you a video because this.
Just let me do the publish.
Yeah. Because, all right, thank you. This is really neat. The robot in this video, just give me 1 second. I'll let you watch this for a second. Look at all the wires in the back of this robot. This robot is very intimidating for people. And when the robot turns around, I'll often hear people make comments like, we've gone too far. And sometimes people will shield their face. They can't look at the robot because it's too intimidating looking. I'm fast forwarding here just for a second. So I want you to see the robot pour the drink. So that'll do for that. When I'm doing a presentation at a school, I'll start by talking about robotics for 5 minutes. I'll demonstrate the robot as I just did for a few minutes. Then I'll get the students up to volunteer to program the robot. And in that, 45-minute segment or 40-minute segment, 10-year-olds can program this robot to wave, to talk. They record their voice and have it come out the robot. They get the robot to, they program in a new name for the robot, talk to the robot, and it responds to their voice the same way you saw it respond to mine. Then they get the robot to track a color, recognize a student, and greet that student by name. 10-year-olds can program all of that in 40 minutes or 45 minutes without any prior experience on the software. Now, they haven't learned how to do that. They haven't gotten education, but what they've gotten is a high level of confidence. And all the way through the process, I say, okay, who could have programmed the robot to wave? Because I got the software projected on the screen behind me. And all the students will put their hand up. I'm like, everybody could do that? Great. Robot talks. I'm like, who could have done that? Everybody could do that? Great. So all the way through, the kids are going, I could do it, I could do it, I could do it, I could do it. But then I show them the video of the life-sized humanoid robot.
Mm-hmm.
And I say, okay, you all said you could do this. Who thinks they could program this? And nobody thinks they can.
Oh.
So then so it's interesting because they've all got a high level of confidence and then no confidence. But I will let them know that the life-sized humanoid robot is using the exact same hardware and software as this little guy. And we'll look at what the robot was doing in that video. The robot's moving servos. I'll say to the kids, did you program your robot to move servos? Yes, you did. So you all could do that.
Yeah.
And then the robot is talking in the video, the life-sized humanoid robot. Did you program this robot to talk? Yes, you did. The robot is listening. Did you program your robot to listen to your verbal commands? Yes, you did. But you've already shown me that you could program 75% of what this big robot is doing in the first 40 minutes of learning about robotics. You've all told me you could do that, and you've shown me that you could do that. And when we do that, it's like you can just see the little heads exploding. They're like, oh my God, I could do anything. And now we've given a whole range of students who maybe weren't as technically inclined or didn't have a strong degree of confidence that they could do programming or do robotics. And we've helped them understand that they can do it. And when we do that, the students start applying technological learning to whatever their passion is in their heart. And so if students are sitting there and they've got a lot of environmental concerns about the plastics in the ocean, rather than sitting there thinking, we've got a big problem and I'm powerless, they think maybe we should make robots that are solar powered that can clean the oceans. And they start thinking about solutions to a lot of different situations around them. But again, the big thing is it's all according to what's in their heart. And when we do that, and when we approach robotics that way, that's where we get the 90% of middle school children interested in learning robotics, or 25 to 45% of high school students, right? Which is 1,000% higher than what schools will typically see. And we've done this across the USA and Canada, from large inner city schools in LA up to the prairies of Canada, down to New Zealand, over into Dubai, right? We've tested these strategies across a broad range of demographics, academic abilities, grade levels. It works with everyone.
Wow.
And I think the reason it does is because we're reaching the children at what they are intrinsically interested in, rather than saying, let's make a robot that will follow a black line. Because the only people that care about that are your most engineering-minded students. And we want all of our kids to be able to program that type of thing, but we have to start with something a little bit more fun and engaging.
That's true. And the way you are mentioning, right, the approach that you came up with, like first showing them the front end, like interact with the robot, and then telling them what goes behind that. So that is definitely something that, can build the interest to the kids. Like they can find something fascinating, and then they will think about, can I build something like that? So thank you so much. It is
My pleasure.
a great approach to have. And I really enjoyed the demo and hope the audience will too. Moving towards our next segment is moreover the questions from the audience. The first question that we have is, we are talking a lot about the robots. So can robots be smarter than humans?
Can robots be smarter than humans? The truth is, in many cases, they already are. But not in all cases. And this is something that we need to understand and maybe define what robotics is and what artificial intelligence is. And really, those two, I guess, industries they're the evolution of the computer industry. Robotics is how computers will physically interact with the world around them. Artificial intelligence is how computers will think. And some computers are already operating in this way. But the big thing is, if we think about robotics, it's what you need is you need a processor chip, you need a sensor to sense the environment, and a way to physically interact. If we use that definition, then things like the doors at the malls that open for you automatically, that's a robotic application, right? There's a sensor that says, I see movement. The processor chip says, oh, when I see movement, I open the doors. Now, in the future, that'll get a lot smarter, and it might run facial recognition software, and it might know that Dennis shops at store X. So the doors might notify store X, Dennis is in the mall. And then that store X might have automated processes that say, when Dennis is in the mall, we send him this Instagram feed or this Facebook post or this text or whatever it might be.
Mm-hmm.
Right? So that's, an example of the evolution.
Mm-hmm.
But, computers can already process mathematical equations at speeds that are tangibly faster than people. So they're already smarter in some ways, but what they're not great at doing yet is being creative and applying solution.
Mm-hmm.
Even when we look at artificial intelligence and they're teaching, 3D simulated bipedal creatures, so humanoids, to walk, they're doing that by running millions of experiments. So they run a whole bunch of experiments. Which ones looked like they were going to be promising? Let's iterate off of those. Let's iterate off of those and iterate off of those. And so when we talk about machine learning, that happens through the ability to run millions of simulations. And the truth is people just can't do that. But or not practically. But the opportunity to take human intuition and problem solving and apply that with artificial intelligence opens up a broad range of incredible possibilities for things that we can learn and do better with. There's examples of artificial intelligence being used in robots in labs, and they've made solar panels apparently about 10% more effective. 10% improvement in the energy output of a solar panel, that's a huge step forward. But you can do that when you've got artificial intelligence. Whereas if you had people and you were trying to run a whole bunch of, 600 or 1,000 or 10,000 tests, that's a lot of process. That's a lot of time. It's a lot of cost. But a computer can simulate that, literally over the span of a weekend, right? And then you can actually have the robot run those physical tests if you want to, or people run those tests to validate and verify the data. So really what we're going to see is a real fusion between technology and technological intelligence, or artificial intelligence, and human intelligence, where if we can put those two together, the people that understand the artificial intelligence, they're going to be advantaged. And it's important to understand this next part. They're going to be advantaged across all careers and industries. This is not, I teach robotics. My goal is not to make a bunch of roboticists. My goal is to get everybody robotics and AI literacy, because it doesn't matter what career or industry you go into, these technologies are going to transform that industry. And if you understand this technology, you're advantaged across the globe. So there's my long answer. You'll notice I give those a lot.
No. Those are very valid points, when it comes to automation, I guess. When we think about robotics or the artificial intelligence and the cryptocurrencies or the blockchain, those are really very valid points that, technology is always there to help human beings to make their lives better, stealing anything away. Some mundane jobs might go away, but it is going to create many more jobs as well.
Yeah.
So thank you so much for sharing. And as we are talking a lot about the robotics engineering and the education related to it, so according to you, actually, what aspects of robotics engineering most interests you?
The aspect that interests me most is really getting children to understand this. It is, I am not intrinsically motivated to build the world's best robot, but I am massively passionate about trying to make sure that the maximum number of children get this education. So I'm, I think artificial intelligence is very interesting. I think that what we're going to do in space exploration is going to be unbelievable, but we're going to go farther and we're going to go smaller than we've ever conceived. And that opens up incredible possibilities for what we can do with medicine. It opens up incredible possibilities for, the fact that mankind can become interstellar, right? And when we look at what's happening up in Mars, this is kind of interesting to me. And I say this to kids, think about the planet Mars. We have an entire planet, and the only things that we know that are moving with purpose are robots. And so Mars has kind of become a robotic colony of Earth. And what they will do over the next 100 or 1,000 years, is they'll start to build habitats. They'll start to have people living up on Mars, doing experiments, trying to, they're talking about trying to terraform the planet. That's an unbelievable undertaking. I don't know if that's possible or not. There are people much smarter than me working on that, but we start to see those incredible possibilities. And I think that, robotics will make a huge, huge impact on our planet in terms of cleaning the environment, in terms of mitigating climate change. There's or climate impact, I suppose, is the more relevant term. So there's so much that you can do with this technology.
Yep, that's very true. And thank you so much for sharing.
My pleasure.
Moving towards our next segment is more about knowing you little more and exploring your career work or volunteering. So you are specifically working on educating the educators who teach robotics programming to kids. So would you like to share more insights about it, and how do you see this need, as well as how critical do you think robotics and computer science education is?
Okay, this next thing I'll say will be alarming to people, and initially when I say these kind of comments, when I do presentations, people think I'm a little bit crazy until I unpack it. But I really believe that children that don't get this education are going to have a hard time finding a job in the next 5 to 7 years. The changes will be that pervasive, and they're coming that quickly. And it's important if we understand that, okay, robotics, self-driving vehicles are going to completely transform the transportation industry, right? That has the potential to displace a whole bunch of people. The technology is already transforming retail, right? You go into a Walmart, there used to be 20 people at the front counter. Now there's, and 4 self-checkouts. Now there's 20 self-checkouts and 4 people at the front counter.
Yes.
You go into a restaurant and there's touch screen ordering at the McDonald's, and there's robotic chefs coming. And there's robotic coffee shops and hotels being serviced by robots. So the hospitality sector and the retail sector and the transportation sector, manufacturing, agriculture, all of these industries are being remade as we speak. And the result of that is going to be that, the forecast, this is a horrible statistic. The forecasts are that over the next 10 years, 20 to 40% of all jobs will be eliminated by technology. And that's a staggering statistic. So we're talking about globally hundreds of millions of people that have lost their job to technology. Now, at the same time, hundreds of million, hopefully, new jobs.
Yeah.
The societal challenge is going to be that these new jobs require different skills than the jobs that have disappeared. So we're going to have a huge task in retraining the people who have lost their jobs. And then we've got hundreds of millions of new jobs. And there's a third category that I think isn't really understood, and that's all of the jobs that are going to be changing and become high tech. And my favorite example, talking to educators, is the education industry, teaching. If the teachers that are getting overwhelmingly hired today, or overwhelmingly getting preferentially hired, I guess is the right term, are teachers that understand programming, 3D printing, robotics, cybersecurity. If you have those words on your resume, you're hitting a skill gap that schools have. So teaching historically is not high tech, but for the next 10 years, until we close that gap within our education system, the teachers that are going to get hired are high tech teachers. So it functionally is a high tech career. And there's one more that I love to talk about with educators, because this one is really surprising, but it really showcases why this technology is so important. I was at a robotics conference about 6 or 7 years ago in New York City called Robo Universe. And I gave a keynote on the changes that were coming and what we needed to do to prepare our kids. And then over the span of 2 days at this conference, I met 20 to 25 people from the fashion industry, which very much surprised me, because I'm at a heavy duty robotics conference. There's industrial drones, assembly line robots, and then fashion designers. And so, the first couple I met, I thought must have a personal interest in robotics, but you meet 3 or 4 in an hour and you're like, wait a second, there's a pattern here. So I started saying to them, you're the 4th person I've met in an hour. Why are there so many of you here? And what they all told me was that if you want to get a job in fashion design, 2 of the most important skills are 3D printing and robotics.
Wow.
And they all put 3D printing first, but they all mentioned 3D printing and robotics. Now, to be fair, I'm at a robotics conference. The people I'm meeting would have a natural bias towards that type of an answer. But I started to think about the reason for that. And here's kind of what I distilled it down to. Imagine that this circle represents all the fashion that's ever been produced in the history of mankind. It's all in here from all the cultures. If you add 3D printing and robotics, what you can do is greater. Right? You can add, with 3D printing, you can make new fashions that have never been created any other way. With robotics, you can make smart clothing that responds to light or temperature or sound or the wearer's own biorhythms. So what you can do is greater. Now, if you own a fashion design company and you're hiring a new fashion designer, do you hire the person that gives you this potential or this potential? Right? And the answer is clearly that you want the greater potential. You want the cutting edge designs. So it's important to understand once these people are available, these people stop getting work. And so, and this is the teacher. Remember, I just talked about the teachers that understand high tech, teachers that don't understand high tech. And it's going to be this way across all industries. If you want to go become a retail store manager and they've got customer service robots, warehouse robots, self-checkouts, this is the manager that understands the technology. This is the manager that doesn't. For this reason, it's critically important that all of our kids that graduate from our schools are these types of people, because we're already going to have a pool of millions of people that are these people. But we have to stop graduating these people. We have to graduate these people. And this is the most, like, this is why I got into this 8 years ago, circling right back around to your very first question. I started to understand this change that was coming and the need for all of our kids to get this education, which is why when we started teaching robotics and looking at it, we were like, how do we engage the maximum number of children and get the kids that are completely not interested in robotics to be interested in this technology? Because they're not going to go into the robotics industry, but they might go into the fashion industry. They might go into teaching. They might go into business, and they'll be advantaged if they have this knowledge. And that's what creates the abundance and the tax opportunity. It's what creates the new job opportunities that helps to employ the people that have lost their jobs. This is so critically important. So that's the part I love.
That's true. No, that is true. And when we are thinking about skill sets, right, it is always a required thing. Even though you are doing the job at the front desk at the moment, everything will not be same. The computer systems has changed everything, right? Billing system or accounting. So even though you're working at the bank front offices or you are working at the MACD, you have to learn certain softwares to enter the billing information for the particular customer or how you pay the bills, right? So those skills anyways you are adapting. It is not anymore like a manual process. So similar way, like robotics or AI or blockchain, they are going to do the same thing actually. So you have to be adaptive actually to learn the new skills that are coming along the way and changes that those are happening. And I'm really enjoying this conversation because I'm learning a lot more on the kids' perspective as well, like how you are interacting with them and how they are looking into these particular areas. So thank you so much for being a guest. Actually, I really appreciate it. And we have learned so many things from your career path or the way you are leading your passion. But to just summarize in particular section, I would like to ask you any particular tip or advice would you like to give to the students or the professionals who are looking to get into this robotics field and looking this as their long-term career option? You can support any books or courses as well to start learning this particular space or exploring this space.
I would say that all educators, no matter what subjects they're teaching, should be looking, doing Google searches. That's where it all starts for everybody. Just get on the computer, do some Google searches about how robotics or artificial intelligence is impacting the subject area that you're teaching about. And then you can start to implement that technology or that thinking into your classroom. When we talk, like I've met social studies teachers that say, I teach social studies, robotics doesn't pertain to me. And I'll say, oh, well, we're in the midst of the largest workforce and societal transition in the history of man. I think that has some social studies implications, right? Like this is really, it's going to be everywhere. The number one thing people can do is start to do research online. There's great information online. If you want to learn about artificial intelligence, just go onto YouTube and type artificial intelligence. And you can start to pick up some videos. And that's going to help direct you in terms of whether you want to do this. You know, sometimes libraries now are putting in robotics programs and stuff for young children. And sometimes libraries have robotics kits that people can rent out or go into the library and use. If your school's not doing it, if you're an educator and your school isn't doing it, and you know the things that I've said resonate with you, people can reach out and talk to us at robots.education. That's the website. That's the whole URL, robots.education, because we help educators understand this technology and bring this education to their kids. And lots of times we hear, we don't have the budget, we don't have the teachers that will teach it. We've been doing this for 8 years. We've got solutions for everything.
Wow.
But you know, for students that are interested as well, really just take the leap and just know that even if you don't know a lot about it today, it doesn't matter where you start, right? 8 years ago, I knew nothing about robotics, or very, very little. The same level probably as every teacher out there or most students out there. And now I'm the CEO of a robotics company, right? You know, that's a crazy.
That's great. No.
But here's one of the interesting things that we have to understand about this transition. I'm a really, really effective robotics teacher because I don't have robotics, you know, formal robotics background. Now, I can't teach super high level artificial intelligence and coding because I don't understand that. But when it comes to engaging students, we do it at an incredible level because I'm coming from a background where I'm not teaching it as an engineering course. Whereas a lot of times robotics instructors are teaching engineering courses, they're robotics courses, but it's really engineering. And those are great, but they only reach engineering minded kids. So when we started, we went to the other end of the spectrum and said, how do we engage these students over here? So my lack of formal background in robotics, and I've been doing this for 8 years, so I've got a high level of knowledge at this point. But when I started, I didn't. But that made it easier for me to communicate with educators and students who were intimidated because I wasn't coming at it from an engineering perspective. So, you know, it doesn't really matter what people's background is or what your level of confidence is. Just jump in and give it a try, because you're going to pick up knowledge that's going to help you on your career and your life path, help you to have a more interesting, a more financially rewarding, a more beneficial life where you can make a larger impact and help people. Doesn't matter what you want to go into. I've had people challenge me, what about this career or that career? And like counselors, therapists, and having this knowledge is going to help you regardless. The only time I've been stumped was by a student that said they wanted to give horseback tours. And I'm like, well, you're going to have a great life if you can pull that one off. But even then, you know, horse care and stuff, that'll all be amplified and enhanced because of technology. So the truth is you're still advanced, or advantaged if you learn this. So yeah, my advice really is just jump in, take that first step. There are courses out there for when you get to higher levels, right, that you can get that education. And it's becoming more mainstream by the day. And people that jump in now and get this education are going to be ahead on the curve. They're going to be advantaging themselves, right? So it's the best time to jump in is tomorrow, really, or this evening or this afternoon, right?
That's true. There is no right time, actually. You can just start exploring. So thank you so much for sharing. And we are moving towards our closure segment, which is leadership. So no doubt that you are leading your area of interest. So what is your leadership style? My leadership style, I guess, relentless pursuit of passion. You know, I try to share my enthusiasm, and I try to share the why, right? So, you know, if we're to talk about who do I think has got great leadership, you know, I would say Simon Sinek. His you know, start with why is so important. And you know, one of the interesting things as well with this whole change that we're talking about is we have to get, you know, if 3% of high school students are interested in robotics, it's probably true that 3% or less of adults are interested in robotics. Of
we want to create this culture change in our schools,
Mm-hmm.
we have to give the relevance, we have to give the why to the teachers. Once teachers understand why this is so critically important, historically what we found is they will make the effort
Mm-hmm.
to understand how this technology will impact their subject area, to get their teachers or their colleagues at their schools interested, or to get their administrators interested.
Mm-hmm.
But it all starts with the why, and that's one of the big things that, if I was to say, I guess if I had a leadership style, it would pretty much be start with the why. Get people to understand why this is so important,
Mm-hmm.
because we have a big lift. We've got a huge job to try to get everybody to get this literacy.
Mm-hmm.
So the first thing is people have to know, why should they care about getting this literacy? Why should they care about teaching this literacy? And once we have that, then everything else kind of falls into place. And it doesn't really matter what the level of knowledge or enthusiasm, or not enthusiasm, what the level of intrinsic knowledge is for people. Educational leaders that get into this are going to inspire children that have the same fears and concerns that they had. Right? So be fearless in taking those risks to try to learn this. And that, I guess that would be my leadership style. I don't know. That's a great question.
Simple one, a simple funda, actually, the way you have mentioned how you want to lead your area of interest. It just simply ask the question why you want to do it, or why it is important. So yeah, thank you so much for sharing and being a guest. This is definitely very educational episode, as well as the fun episode to learn more about robotics engineering. So thank you. I really appreciate all your time and consideration.
Thank you. Appreciate it. Take care.
Yeah, take care. Bye.
Bye.
All right. So this is all about Dennis, and this was completely a fun episode, as well as we learned a lot about robotics engineering and the way Dennis is trying to motivate or make kids learn robotics more and more. Before we close our today's episode, we have a closure quote from a very famous writer, Mark Twain. The quote says, "In the first place, God made idiots. That was for practice. Then he made school boards." So on that quote, we are closing today's episode. See you guys in the next episode. Until we meet, happy leading. Let's lead together. Stay safe. Bye for now.